The final numerical method in the open methods is the Brents method. And Brents method says finally that, okay, we have many methods actually, both open methods and bracketing methods. And maybe we can combine them to have a hybrid method. And we can use the reliable bracketing method and speed open methods. So basically it applies a speedy open method wherever possible, second or inverse quadratic, and applies a reliable bracketing method where, if necessary actually, when root falls outside the bracket. And the bisection here is the key, because that always finds a root, but it's slower. That's why it is preferred in cases where root falls outside the bracket. It guarantees an estimation, so we will use this reliable bracketing method as well. So these will be used in an order to decide the root value. Yeah, it's repeated until the root is located to within an acceptable tolerance, and as might be expected, the bisection dominates at first, but as the root is approached, the technique shifts to the faster open method. So initially we can start with bisection to make sure that we converge towards the root, because if we start with an open method, it may not, we mentioned about the issues, it may not converge, it can diverge. Rather, we start with bisection, converge slightly, then we go to an open method, a second method, and quickly go to the root. And for this, MATLAB has a function which is called F0, and this is developed by Clive Moller in 2004, and it's very reliable to find roots of any equation. You can check this. And a simple pseudocode, F0 simp, is provided in your book. That's why I will quickly talk about this F0 simp, because it's actually a simplified version of F0 and shows in the algorithm the bracketing and second method and inverse quadratic, etc. So you should be aware that it requires another function f that holds the equation for which the root is being evaluated. Of course, we will call this equation function because we need to find the f function values for the guesses, let's say. And let's check that in the next slide. In this slide, we have the simple MATLAB algorithm for the Brents method, and it's F0 simp, as I mentioned in the previous slide. This is a simplified version of the F0 function in MATLAB. And I will quickly go over this, not mention all the details, but mention that how it goes from bisection to open method. So basically, in the beginning, it makes a condition evaluation of the functions to find if there is any bracketing for the root, and if these can be achieved, here it will choose between open method and bisection method. For example, if a equals c, then it will use this, which is second method. And of course, inverse quadratic is more accurate if we have two separate function values. It calculates them here, the function values, two separate of them, a, b, c, and fa, f, b, f, c. So if we have three of them, we will use inverse. If we have only two, because one of them is equal, as we mentioned earlier, then we will use second. Also, we will check the bracketing, as we said earlier, and if there is a bracket and the root is between, that means we will check the lower bound function value times the predicted function value will be smaller than 0. Then we can use bisection. And you can see that bisection and these open methods are used in, together to be able to find the final solution over here. You can by yourself go through in this in more detail. I will just wanted to quickly show that we use both of these together in this algorithm.